Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. I am happy to have Automotive Seminars as a sponsor for the show. Now, if you're not familiar, Automotive Seminars is a diagnostic technician training company. They've got a website that there'll be a link to in the show notes. And what they offer is top-notch training to technicians like us in the field. I've been taking their training courses for years and have got a ton of benefit out of it. They've got top-notch instructors, John Thornton, Scott Schotten, Scott Manna, and every other month they've got a 2-night course that you can sign up for. Join in, ask questions, and afterwards, you've paid for the course, you can access a recorded version whenever you want. You can rewatch the class 2 years later in case you wanted some details on it. And that is a fantastic feature. So make sure to check out the website to see what courses they have available and what's coming up in the future. Hey, what's going on, automotive world? Welcome to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I'll be your host once again for this week's episode. Thank you so much for joining me. This week on the show, I'm going to be talking about air suspension systems, specifically the nitrogen-filled systems that we see primarily on the Stellantis, Jeep, Ram, Dodge, Chrysler platforms. So you've probably seen these in the Jeep Grand Cherokees. It's the most common, at least that we're in touch with out in the field, is those Grand Cherokees, or they've had it the longest, I should say. Also, the Dodge Rams have it in some of their applications. We do see it in a few other vehicles, and we also see it in vehicles outside of the Stellantis platform with newer applications. We recently had a 21 GMC Yukon that had the system, and a Volvo, I think it was XC60, some sort of SUV platform for a Volvo, had a very similar air system. Now, what these all had in common was there is an air tank reservoir to the system, which is not common with the traditional air systems, or maybe they had one, but it was not this aluminum style with a fill fitting that you see on, again, the Stellantis platforms and these newer applications. And these systems are filled with nitrogen from the factory, and if you empty the system severely or there's a major leak or component replacement, according to service information, you're supposed to fill them back up with nitrogen in order to properly service the system. Now, this is to keep humid air from the atmosphere from entering and preventing any ice or internal corrosion of the components. That's the idea. The other part of it is with a pre-charged system, which is what this is, right? We have almost 200 PSI of pressure in these air reservoirs and in the springs at any given time. It can quickly fill the system because we have pressure on demand rather than having to build it with the compressor itself, right? And that's something to understand about these systems is, yes, we do have a air compressor that's built into the system, but the job of the compressor is not to build the pressure that's needed to raise or lower the vehicle, mostly raise the vehicle, but more so to move pressure from one spot to another, or to assist in the moving of pressure from one spot to another, just to kind of push the air through the system, if you will. It is not designed to build the pressure. So you probably have seen one of these vehicles come in where it's got codes for low air mass, right? The charge is low. And yes, it has a compressor. Yes, the compressor will run, but it's not able to build that pressure back up in the system. You're going to have the tank and the connecting equipment in order to fill that. Now, that's kind of what I wanted to talk about today on the show is if you're seeing these vehicles come through your shop, they've got codes, they've got issues, maybe you're replacing components, it's actually not that bad to get set up to perform the service on these vehicles. And again, you get set up for the Chrysler systems, you can transfer this over to these other systems that seem to have a very similar air suspension setup. Now, I did a little bit of digging, not a ton, but it looks like Continental is the manufacturer that makes the equipment for all of these air systems. This episode is brought to you by AutoRescueTools.com and Isaac Rodell. If you are looking to get into module programming, but you are not sure what kind of laptop you're going to need or how to set it up for programming, Isaac is your guy. He can set up laptops specifically to do control module programming for specific brands with partitioned hard drives and all the software that you're going to need to do this. He also sells key cutting equipment, scan tools, and other diagnostic equipment. I bought some stuff from him in the past, and the support is phenomenal. So I highly recommend checking out the website. Again, that's AutoRescueTools.com. The link will be in the show notes. Now, they're going to have their nuances and their differences, but what I will say is spending some time on this 21 Yukon, and we had a challenge with this one, and I'll share you what that is exactly. Maybe it's not a unique situation, but it was definitely strange at the time. The process for filling the system, although the scan tool interface is different, it definitely mirrors how you were filling the system with a Dodge Jeep Ram system. So again, not exactly the same. Scan tool interface is different, but you can see the overlap. And if you're set up for one physically with the gauges, the tank, the hose, the quick disconnect, it works on these other systems. And this is just a 134A fitting. So you could go buy a quick coupler for the low side of a 134A system, and you'll have the fitting that fits on these air tank systems. Now, Dorman does make a hose set with the quick disconnects and everything. You can just buy it. I don't know, it's a couple $100s or something like that. You could probably make your own hoses if you wanted to. Go to a hardware store and figure this out, and then go to your local supplier for like welding equipment, and you can buy a tank of nitrogen, put a gauge set on the top, hook up the hoses, get your quick disconnect, and connect up to the system. Again, check out the Dorman kit if you just want kind of a pre-made ready to go hose set. And then again, you just need a tank of nitrogen and some gauges, and then understand how to, work the regulator on the gauge set. But it's not terribly complicated. If you work in a shop, you're probably familiar with oxyacetylene. And so, although it's not exactly the same, it's the same idea with the regulator and gauges, and you can figure it out. So what I'm saying there is it's not terribly expensive to get set up to do this. You may already have the scan tool capability, and you can do this. Let's come back to the scan tool thing. You can maybe do this with aftermarket scan tools, but I have had issues. But you might already be set up with the scan tool capability to do so, and then you just need the physical component in order to charge the system. And you can get set up for this for less than $300-400, and you could be ready to go. And you can charge that for one job, in my opinion, or make that up in two jobs at the very least, and then the equipment is paid for. So if you're seeing these vehicles come through your shop, and you're servicing them, you're doing the suspension work, or even just diagnosing like we do. We don't actually do the suspension work ourselves, but we get shops calling us saying, hey, we either have this code for this air suspension system, or we replace this component on this air suspension system, and now it's bellied out, it's low, and it won't go back up, the compressor won't run, there's codes. So then we come out and we'll charge it, and then we charge for the charge, right? We don't do it every day, but it's a nice little add-on service. And we kept running into scenarios where, we come out, we diagnose and say, yep, it needs an air charge. And then you're probably going to have to find the leak, right? That's the other thing. These systems are prone to leaks, just like any other air suspension system is. It seems to happen a lot at the fittings, especially on the Rams. If you have a Ram that has a low air mass for the air suspension system, go to where you fill it, which is above the frame rail on the right rear of the vehicle. Pull out the inner fender liner. You'll see two ports, actually. You can fill the system from either port, but almost guaranteed, if those haven't been changed, one of the O-rings on the fittings is going to be leaking. You just spray it with soapy water when there's a little bit of pressure in the system, and then you can see the bubbles coming out. And then you can actually just change those fittings and the O-rings, and then you're good to go. Now, not saying it can't leak from other places. Of course, the air springs themselves can be the source of a leak, but that's a very common one on the Rams and a place to take a look for. So, again, where we were running into this is we come in and we diagnose, yep, it's low on air mass, and then you're going to have to get it to the dealer or find a way to get it charged, and then you're going to have to, figure out why it was low. And so we kind of just leave it open-ended. We really didn't give them much of a conclusion at that point. Now we can offer to charge it up and then, decide with them, do you guys want to spray it down and try to find a leak? Generally, I kind of push the shop towards, that rather than us. But sometimes we'll do that, grab some soapy water and figure out, again, there's common points for leaks. And then sometimes we're just coming in and doing the charge after they've done the repair on the system. And that's where we got involved with the Yukon and the Volvo, same things. When it's completely empty or empty below a certain point, that compressor is not able to recharge that system up to, the 175 to 200 PSI that it needs. You need to put that in there from an external tank. So when you're doing this, the way that it's going to work is you're going to take your tank, you're going to set your regulator to the pressure, and you're going to have to look in service information because different applications will have different pressures that it shoots for. Again, 175, that's pretty common for the Jeeps. I had a newer Jeep Wagoneer that was over 200 as the set point. I want to say the Yukon was over 200 as the set point. So you're going to have to adjust your regulator to whatever the set point is for that particular vehicle. You can usually find that within service information. And then you're going to connect up and you're going to fill the tank to that pressure. Now, I will warn you here, you can go higher on your regulator on your gauge setup. You can dial that up to 400 PSI if you want, and you can put that into the air tank if you want, but eventually you're going to go beyond the safety point. And even if you don't, here's what can happen. You fill that tank up to 400 PSI, right? Because you weren't paying attention to where your regulator was. When the system then goes to move that pressure from the tank to the air spring, you can pop a line right off of that air spring or pop a hole in the air spring. It's usually the line that will actually bust off of it. I've seen that happen. And that's when you have the pressure set too high, and it's an aluminum tank, so it'll hold that in the car. But then when you go to move it to an air spring, that's when you're going to have problems. So you can definitely overcharge these and cause damage to the system. So pay attention to what the set point is for that vehicle so that you don't put too much pressure into that reservoir. But what you're doing is you're filling the reservoir with the set point of pressure, and then you're going to use the scan tool to fill each air spring, or maybe just the air spring that was replaced, but generally speaking, you're going to do a fill for each spring individually. Depending on the application, it may be a full fill or a short fill option, and then you can decide, okay, is this thing completely empty, or is it only partially low? You can play around with that depending on the scenario that you have, but this is a scan tool function that is now taking the pressure from the reservoir and it is going to move it to the spring of your choosing. Now, once you've fully filled up each air spring or the spring that you're after, then what I will do at that point is one of two things. I will either run an air mass check, and this is specifically with the Chrysler system. And what that does is the actual air suspension control module will look at the pressures in the springs and in the reservoir and calculate basically it's a pressure to volume ratio and give you an okay, a too low or a too high after you run that air mass check. And so then you can tell from that, is the system full enough, right? Because when you fill the reservoir with your external tank, you're just filling that reservoir. The system has valving that closes it off to the air springs until it's triggered by the control module. And again, the compressor's there to assist pressures from moving from one spot to another. But really, it's the valve block that's going to move it from one particular area to the next, right? And so after you've taken the pressure from the reservoir and gone into one of the air springs or all of the air springs, that pressure in the reservoir is going to drop. Okay. So then running that air mass check will give you that total, like, hey, it needs more air, or it's good, or it's got too much. That's possible too. And then I will add more using the tank, right? I'll open up the valve on the tank, put some more into the reservoir, and then I will run the air mass check until it comes back as okay. Now, if you overfill it, there is a vent method that you can use with the scan tool as well to release some of the pressure. So that's an option if you go too high, but running that air mass check throughout the process really is important. I'll fill the springs, I'll run the air mass, I'll adjust if needed, I'll run the air mass again. And then once it's in that okay range, I filled all the springs, then I'm good to go, and obviously you can check for leaks if you want to as well, but that's the actual fill process that we go through. Now, I do want to point something out here on the scan tool part of it. I have had the best luck, or I should say, I've had really bad luck using aftermarket tooling for this. For some reason, and this extends past just Stellantis platform. Obviously with the Volvo, I don't even think I had much options for anything on the Volvo outside of using Vita. It was a newer one, but on the GM, I couldn't do anything on this with aftermarket scan tools. Now I tried Autel and Topdon. Maybe there's another one out there that does it, but I ended up using GDS2 and it was the only effective tool. And even then it was not user-friendly. It is a very difficult system to get the hang of. It's not intuitive in my opinion. And I had to make a lot of notes on it. So if I go back to it, at least I understand what's happening and the process that you want to go through. I think Chrysler's a little bit easier to work through, but even Chrysler can be kind of difficult to work through the processes. And again, using an aftermarket tool, especially on the newer Chrysler stuff, just did not work for me at all. I had to use YTech. So to sum that part of it up, my suggestion is if you're going to get into this and you're going to try to run these fill procedures and check procedures on the system, use the factory tooling. It seems to be the best to interact with these air suspension control modules. Okay. Now, what if you have problems with the system? Now, number one, the compressors can fail. And usually what happens is they've overheated from moving air back and forth too many times. And you'll hear the compressor running, but it's not doing what it's supposed to. It's a pretty common failure to have a compressor go out of one of these systems. So that's just a replacement. And yeah, you can charge it up and check the air mass as well. But I want to talk about another problem with these systems that I've seen twice now. One was on a Jeep and one was actually on the Yukon that I was referencing. So these air springs that are installed on the vehicle, right? And they're exactly that. It's a big strut-like assembly with a boot that is going to hold the air pressure. And then there is a valve on the top that connects it to a line that goes to the valve block and compressor and the tank of the system. Okay. So that's how air gets to the air springs. But there is a valve that screws into the top of the air spring that has a check valve within it. Okay. Now the purpose of this check valve is if you take the line off of the air spring, this check valve will seat and it will allow you to take the air spring out and still have air in it. It's not going to completely evacuate all of the air within the air spring. Okay, so this is a one-way check valve that allows air into the air spring, but not out of the air spring. Okay, well, you might say, well, how do you lower it? When you thread the line into this valve, right? So the line that actually goes into the top of it to feed it air, if, and this is a big if, the line is seated properly, it displaces the check valve, right? So when the line is attached to the air spring, the line itself basically pushes down the check valve. So then it is a two-way. There's no more valve, essentially. You can put air into the spring and air can come out of the spring, but only into the line. And then as soon as you unthread the line, pull it out, that check valve seats again. So there's a TSB on this, or star case on this, that when the line gets pushed up into the fitting, it will actually not displace this check valve. And the problem is air can go into the spring, but it'll never come out. And so when you're doing your fill process or your level calibration, which is one thing I didn't mention, you can do a level calibration as well with the factory tooling. It will put air into that spring, but it'll never be able to release it because that check valve isn't displaced. And the way this happens is the fitting that you actually use to tighten up the line to the air spring, it has a collar on it, kind of like an old compression fitting. It's like a brass collar, and it can slide down on that line, and it makes it so the line doesn't actually displace the check valve. If you're not understanding that from the audio, take a look. Just search for the star case. Maybe I'll try to find it and put a link in the show notes so that you can visually see it. Once you see it, you understand it. But if you don't know that's a thing, you don't know that's possible, and that was me on the first time I dealt with this on a Jeep Wagoneer, is the right rear corner was just like way up there. And this thing had been, this was like a rebuild auction car, and they had completely changed the connector at the air suspension control module, and like butt connector wired up every single wire to it. And we were really wondering if there was some weird issue where it was sending air to the wrong spot. We looked at the valve assembly to make sure all the lines were put into the correct place. And it just ended up being that the line had been pushed up to the point where it wasn't displacing that check valve. So this is a really important thing. And again, they have a star case on it, so I'm not the first one to deal with it. But I saw it again in a different way on this Yukon. So this Yukon, they had replaced the air spring with an aftermarket assembly. And when they did this, the aftermarket assembly, if you imagine the left front of the vehicle where this was, and it sits into, the top of the spring sits into a mount that's on the frame rail, the metal portion of the frame rail kind of comes over the top of the air spring. And then there's a hole, and then the line comes in the middle, and that's where that valve is. And this valve is the same setup as on the Jeeps, right? Check valve goes into the top of the air spring, has a check valve that the line is meant to displace. Well, the aftermarket spring sat down further within this, underneath the frame. And so you couldn't get to this check valve when the air spring was installed, right? And so you have to tighten this up with a wrench. It's got a hex on it that you thread it down and you tighten it up. Technician couldn't get to that. So what they did to make this work is they took another check valve and put it on top of that check valve, right? So they screwed one into the other, and then it protruded up enough above the frame rail so that they could tighten it with a wrench. Hey, great. We modified it. We made it work. Well, the problem is one check valve on top of another doesn't work. And so the top check valve, but basically both of them were allowing air in, but that bottom check valve wasn't displaced at all. And so we had the same situation. Air could go into that air spring, but it could not come out. And that took me a really long time to find out because I didn't know that they put two on there. And the GM interface with the scan tool was even more challenging to use. I spent hours on that car trying to figure out what was going on. And then finally talking with the technician and then looking at it, because you couldn't see that there was two if you just looked at it from the top of the vehicle. But then I'm talking to him. He's like, yeah, I just put another one on top so I could get the line on. And I'm like, oh, okay, that's what we're dealing with. And as soon as we got that all figured out, I think they ended up getting a OE air spring on that one. That was the only thing that ended up working for that car. But anyways, I just wanted to share that on the air suspension systems. They can be tricky to work with until you understand them fully. Again, I'll try to put a little bit of information into the show notes here, and hopefully the information in this episode helped as well. But I'd like to thank everybody for listening, and let's get out there, start fixing the world one car at a time.